There are three parts to this question. First of all, we need to construct the two-way probability table for this function. Secondly, we need to find a value of a which is consistent with this being a valid probability distribution function. And thirdly, we need to use our results to show whether or not x and y are independent. So the first stage is we need to write down the two-way probability function. So this is our probability distribution function, and it's valid for x equals 1 and x equals 2 and y equals 1 and y equals 2. And we can now fill in the various probabilities from our function. So in the first cell we have 2a, the second cell we have 3a, and then 3a, and finally in the bottom right hand corner 4a. We can now use these to calculate the marginal probabilities. For example, we add together probabilities for y equals 1 to get the total probability of 5a, and for y equals 2, 7a. For x equals 1, 5a, and for x equals 2, 7a. So it follows that for this to be a valid probability distribution function, the total probability must be 1, or 12a must be 1, or a must be equal to 1 over 12. Next, we construct the probability distribution table using the value a equals 1 over 12. This is just a matter of putting in particular values. And again, we can calculate the marginal probabilities by taking the row and the column sums. So we have 5 over 12, 7 over 12, and again 5 over 12 and 7 over 12. It follows that the probability that y takes on the value 1 is equal to the marginal probability 5 over 12. Now, we want to calculate the conditional probability that y equals 1 given that x equals 1. So we calculate y equals 1 given that x equals 1 is equal to the ratio of the joint probability that y equals 1 and x equals 1 divided by the marginal probability that x equals 1. Now we've already calculated these values from the table. The marginal probability that x equals 1 is equal to 5 over 12. The joint probability y equals 1 and x equals 1 is equal to 2 over 12. Therefore, we can calculate the conditional probability y equals 1 given x equals 1 is equal to 2 over 12 divided by 5 over 12 is equal to 2 over 5. So therefore it follows that the conditional probability y equals 1 given that x equals 1 is not equal to the marginal probability that y equals 1, and therefore y and x are not independent random variables.